We're still in the world of acids and bases. We did in the last one, we started with the pH calculations, and remember the pH is the negative log of the concentration of H3O+, which is the hydronium ion. Also, don't forget that little thing of Kw, concentration of hydronium times the concentration of OH- is equal to 1 times 10 to the minus 14. Because we're going to continue with examples here now. Here is another example. In this example, they ask us, what is the pH of a solution containing 0.25 grams of magnesium hydroxide, MgOH2, dissolved in 0.5 decimeters cubed of water. Okay? Now, let's just take this as an example. We say, first of all, let's put down a chemical equation. Is MgOH2 plus H2O, and we say that's going to go across to Mg plus 2 plus 2OH minus, and let's say what are we given? All right, over here we say 1 plus 1 goes to 2 and 1, therefore 1 mole of the salt goes to 2 moles of the base, because this is the conjugate base, isn't it? Okie dokie then. So now where are we going? We're saying, all right, let's now say, what are we given? We always said, right, given first. Given, they've told us 0.25 grams. And they've told us a volume, but we'll get to that. Where do we head for first? We always head for number of moles, don't we? That's where we're after, is the number of moles. So we need molar mass. Whoops, sorry. I wrote that as molar. It's molar mass. And the molar mass is 24 plus 16 plus 1 times 2 is 58 grams for every mole. Therefore, number of moles is equal to 0.25 mass over molar mass over 58, which is going to be 4.310 times 10 to the minus 3. Now we are at moles, means we can go through the mole hole, through the tunnel. Therefore, this reacts in the ratio 1:2. So what am I going to get out? I am going to get out 2 times 4.31 times 10 to the minus 3. I'm then going to get out over here 8.621 times 10 to the minus 3 moles of OH minus. Let me not put it in concentration figures because that's not correct. Moles of OH minus ions. That's what I get, is it not? What do I do with that? Well, what am I looking for? I'm looking for concentrations. Don't jump ahead here. I know. We said concentration of H3O we're looking for. We'll get to it. We say, right, therefore the volume that we were given, the V, is equal to 0.5 decimeters cubed. Thus, the concentration is equal to 8.621 times 10 to the minus 3 divided by 0.5. So my concentration is 0.01724 moles per cubic decimeter. This is the concentration of the OH minus. We worked out the concentration of the OH minus. The moment you are given a base, you work to concentration of OH minus, because we're then going to change it to concentration of H3O. Because remember, if you add a base, an OH, the concentration of H3O drops. Why? Because of this formula here, concentration of H3O plus times the concentration of OH minus is 1 times 10 to the minus 14. Therefore, look what we've got. Concentration of H3O plus times 0.01724 must be 1 times 10 to the minus 14. We're always targeting the OH, right? Therefore, the H3O plus, hydronium, is that divided by that, and the answer comes to be 5.8 times 10 to the minus 13. And therefore, the pH is the negative log of the concentration of the H3O plus, which is, in this case, negative log of 5.8 times 10 to the minus 13, which is equal to 12.24, 0.714, basic acid. I'm up here, so I am in the basic region. So far, so good. Let's look at it the other way around now. We're going to do it in reverse. Given, let's have a look at another example. Another example here. Let us say we are given a pH equal to 13. Calculate the concentration of the hydroxyl ion. Okay, meaning that's the OH concentration, that's what they want. Remember, they have given a pH. So they've said pH is equal to minus the log of the concentration of the H3O ion. They've told us that the pH is 13, must be equal to the negative log of the H3O. Therefore, minus 13 must be equal to the log of the H3O ion. Therefore, the H3O plus must be equal to 10 to the minus 13. Right? Straightforward. And now, what are we after? They want the OH. Look, they want that. So we know that the concentration of H3O plus times the concentration of the OH minus, let me take that away, the OH minus is equal to 1 times 10 to the minus 14. Therefore, you can now say 10 to the minus 13 concentration of OH minus must equal 1 times 10 to the minus 14. Therefore, we come out with concentration of OH equal to 0.1 moles per cubic decimeter, or moles dm minus 3, like so. Okay? You can see the similarity here in the two. Given a pH, you start with the pH. Work out the hydrogen. If it's an OH, you're going to use the formula that links H3O and the OH. All right? I have seen 1 or 2 students in the past did a POH. Just be careful if that one comes up somewhere. It might confuse you. It's easier to work with pH and just go with the other one. I generally don't use the other version. So just try and stay with one version that you know, because the recipe is the same for each one. We're now going to talk about something called hydrolysis of salts. Hydrolysis of salts. Okay? This is all ionic salts not containing H plus or OH minus as an ion. Okay, right? So we're going to talk about these salts. When these salts hit the water, so we've got these salts plus H2O, they then basically split into their ions. Right? But just before we do that, I want to look at something else, an anion and a cation. Okay. I want to say that this one is called another negative ion. That's how I remember it. Another negative ion is an anion. Now, the cation is obviously the positive, so this is the negative version, and a cation is positive. It was just an aside because the term comes up sometimes in this section that we're looking at. Now, let's just look at mixing something. Let's look at the salts. Let's look at salts that we get from mixing strong, weak with strong and weak acids and bases. Now we're going to do it this way as well. Okay? So we're going to be mixing strong with strong, weak with weak, and strong and weak and strong and weak. Let us start off with something that we know is a strong acid and a strong base. So first of all, strong acid plus a strong base. This is going to give us, and in all cases it's going to give us salt plus H2O. Now we're going to get that in any case, but we want to see, is this salt acidic or basic? That's what we're after here. Now obviously it's acidic if it generates an H, and basic if it generates an OH. A strong acid and a strong base is the proverbial HCl plus NaOH going to NaCl plus H2O, and when we put that salt in water, you get Na plus and Cl minus. This reaction here is called this is our reaction where we basically going to do, it's like the antacid, isn't it? Okay, that one. We are going to essentially put these two together to nullify each other. Okay? And you can see that the salt here is neither acidic nor basic. So this process here is when we do the hydrolysis. It's not going to give us a salt that's basically or basic or acidic, is it? It's going to be a neutral salt. In essence, do you want to know? You've basically got a strong plus a strong. Those two, in essence, cancel. Okay, don't quote, but just as an aide-memoire, to look, a strong and a strong, they cancel, so my salt is going to be neutral. Let us now take up the next one. The next one is going to be section number 2. Oops. Number 2 is I did a weak acid and a weak base. Weak acid plus a weak base. I am still going to get a salt plus H2O. We're still going to get that every time. But you can see, let's just see, do our little thing. Weak, weak, okay, therefore they cancel. So the salt, okay, in this case, the salt could be acidic, neutral, or basic. It could be either. All right? It could be any of those three. Okay, this is a great multiple choice question, isn't it? You can see it already. Okay, a salt of that, the hydrolysis gives us a 1, 2, 3, or none of the above. Therefore, it depends very much on the acids and the bases themselves. The weak base, I actually didn't really write that out, did I? A weak base over here. Oh, gosh. A weak base over there. So that can be either, because they cancel out pretty much, but it's so weak that it could go slightly either way. Now let's get to the nitty-gritty ones. 3. I did here strong acid, weak base. Strong acid plus a weak base is going to give me a salt plus water every time. But now let's use the little cheat code and we say strong, weak. It's going to be strong after. So it's going to be towards the, let me just write that out and not say strong there. Just say the strong. There's not enough of the weak base to get rid of all the acids, so it's going to leave an acidic. Right? So that salt is going to be acidic. When I put it into water, it's going to be acidic in the water. The next one that we're going to look at is obviously the last one, is the other version of that. Number 4 is going to be a weak acid and a strong base. Weak acid plus a strong base. What's going to happen here? Once again, let's use the cheat. Weak, strong, it's going to give me a basic salt. So when I put that in, okay, I'm going to get OHs coming off it. Okay. Then when the salts formed by the acids and the base combine are hydrolyzed, they're dissolved in water. So when I dissolve this with hydrolysis now, so I've made that salt, now I put it in the water. What do I get? I get an acidic salt. Over here in water, I end up with a basic salt. So it's going to turn my water basic or acidic depending upon which is which. All right? How did we form NaCl? Here's a type of question. All right? They say, let's look at a few salts. They ask us, what acids and bases would you use? Let's say, all right, let me just get rid of you. Back to black. Put the blue pen away. And we say, let's look at a few salts. How did we form NaCl? Well, the clue comes from there. It must have come from HCl. Correct? So therefore, it's going to be HCl plus what? Another salt. All right? And it's probably going to be NaOH. So, okay, what about CaCO3? What about CaCO3? All right? Let's put it into water. Let's put CaCO3 into water, shall we? Here's a salt. Let us see if this salt, when we hydrolyze it, let's see if it gives us an acid or a basic salt. So we've got CaCO3 plus H2O. Let's have a look. We have a Ca plus 2, a CO3 minus 2, and we have over here an H plus an OH minus. And what do we get? We actually get a reaction. Normally that would go to that. But what do we get? We get Ca plus 2 plus HCO3 minus plus OH minus. It has given off an OH minus. Therefore, it's basic. Right? So when we put the salt in the water, we can see under hydrolysis, it's caused the solution to become basic because this is now free. Okay, that is free. Let's do one more of these. What about ammonium chloride, NH4Cl plus H2O? This we know goes to NH4 plus a Cl minus, plus an H plus an OH minus. Okay, I've just done a dissociation. This over here actually goes to NH4 plus goes to NH3. All right? Because I know that if I put NH4 in water, remember the reaction? NH4 plus H2O. What happens? I get NH3 plus H3O, which means acidic. So this reaction here, what happens is I actually get this NH4 goes to NH3, plus the hydrogen goes off and joins the H2O, and the chlorine sits. So I end up with NH3 plus H3O plus the chlorine ion that sits. So the solution will be acidic. All right, that's the way we're going to approach those problems. We are looking at the result of what happens when I put the different salts one into the other as a hydrolysis. Okay? Now, I want to just before, I'll probably stop this video and we'll start the next section, because the next section I'm going to look at is in fact titration. Okay? But before we get to that, let us look at the concept of neutralization. Okay. Generally, we're going to put an acid plus a base to get us a salt plus water. Those are generally going to be the kinds of reactions we're going to be doing now. And in a titration, it's experimental. We're going to go through how we do this, what we do, etc. And just do learn, because if any of you take chemistry in engineering or in pure form, even if you're going to go into it from a point of view of medicine, you are going to need to know how to do these calculations, and more particularly these experiments. So do you know what it's worth? Because not a lot of the experiments are done in the syllabus anymore. Therefore, what we do is we're going to go through that experiment in a little bit of detail. I'll be back with you and we'll carry on with the next one, where we will start talking about the neutralization and titration reactions. Cheers. Have a good one. Bye.